Okay, it's Calc BC, Unit 1, Day 2. And we're just going to take notes on our own sheet of paper because there's just not that much benefit to me giving a handout. So just grab your own piece of paper. So we're going to be looking today at equations and inequalities. Okay, so this is going to summarize several days that we spent last year in Calc AB. Before we get into that, in general, when we solve inequalities, we're gonna write our answers in interval notation. So just a quick reminder of what that is. So if you had a picture like this, the way you used to write it is you'd say 2x is greater than or equal to 2 and less than 5. That interval notation is going to be bracket 2, comma 5, parentheses. So bracket is for solid dots or equals to. Parentheses are for open dots. Another quick example might be something like this. And so before we would have said x is less than or equal to 3, but now we're going to say negative infinity to 3. We always put parentheses on infinity because you cannot obtain infinity. So that's just a quick little interval notation. So inequalities. So this first one is going to be a rational inequality. That's already kind of nicely ready for you. So we always want to get everything on one side equal to 0, compared to 0. We also, if it involves fractions, get a single fraction. Then factor it, find its roots, its x-intercepts come from the top, and the bottom is going to be vertical asymptotes. And then we do a line check. Now, the thing you guys got to watch out for is when you have repeated roots or repeated vertical asymptotes to even powers, because they're going to bounce off the graph. That's where the graph is. It's going to have an x-intercept or something, but then it's not going to go through and change signs. So the true false conclusion won't change signs either. So the ones from the bottom have to be open dots because they're not part of the domain of the problem. They are vertical asymptotes. The ones from the top will be solid if there's this bar. Otherwise, they would be open also. So let's keep track of this guy. I usually like to put a little star next to him or something. It's easy to forget. Okay, so then you're going to test a value and you tell me what you're going to test. I like to test far right on rational and polynomial inequalities because everything's usually positive, 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 positive. It's all positive, which is false. True stays true, false, true. So your answer is going to be negative infinity to negative 2, parentheses, union 2 all the way to 4. Don't break it up. If you do, I'm going to take off points because it's just unnecessarily messy. All right. Let's do a polynomial inequality. So that's a rational inequality. This is polynomial inequality. You want to get everything on one side compared to 0. Then you want to try and factor it. Now, some people might be like, oh, yeah, x minus 2, x minus 1. Nope, because we need an x cubed. So there's this thing called the rational root theorem, which can help you identify possible roots. So it's a p over q. This is p, and the coefficient of the first term is q. And so it's all the possible factors of 2 divided by all the possible factors of q. Now, if q is 1, then that's nice because it's really just going to be plus or minus 1, plus or minus 2. And then what you want to do is check these by plugging them back in here and seeing if they give you a 0. Now, I usually do that. I'm going to say 1 minus 3 is negative 2 plus 2 is 0. All right, positive 1 works. Perfect. So test in head to see if get 0. Okay, so 1 works. So now we're going to use what's called synthetic division to divide it out. Now, synthetic division doesn't have anything to do with the rational root theorem. It's just a nice tool you can use to factor things out. Or you could use long division. So synthetic division, what you do is you put the root, the 1, then you put the coefficients of the original equation. Any missing terms have to have a 0. So this is there was no x squareds, so we got to put a 0 there. So then we drop the first number down, and then we multiply by this number, and put that number here, and then we add them, and then we repeat. And at the end, you should get 0 if you found an actual root. If you didn't, then you either picked the wrong number, you did your synthetic division wrong, you forgot the missing term. So if you don't get a 0, double check everything. You shouldn't get a 0, don't fake it. I'll know if it's. Now what we've done is we've divided this root out, which comes from x minus 1. And then this is what's left. Now this is going to be 1. If we take a cubic and we divide by x minus 1, the first term is going to be x squared. So this is going to be 1x squared plus 1x minus 2. Now at this point, you could do rational root theorem again. Check 1, check all these. If there's another rational root. Now, by the way, rational root theorem only works if there's actual rational roots. You can get irrational roots, have like square roots and stuff. But at this point, really, as soon as you get down to quadratic, you should just use regular factoring methods. And if you can't factor it, that means it probably isn't factorable. And rational root theorem is not going to help you. So you do quadratic formula. So this is going to be plus 2 minus 1. Now, I think I'm going to rewrite this with the x minus 1s together just to make sure I recognize that they're to an even power there. So x equals 1, x equals negative 2, a little star next to this guy. We're going to do a line check. So solid dots, both of these. Test a value. I like testing far right. Write down what you test. Positive, positive, false. Stays false, true. So the answer is negative infinity to negative 2. And some people would say, oh, that's it. That's a solid dot, though. Union curly braces 1. That's called set notation. It's just a single solid dot. Now, if it was an open dot, we wouldn't have put it. Okay. Let's see. Let's do some with trig. So we'll say find all solutions on 0 to 2 pi. So usually with trig, you're going to be restricted to where you want to find answers because otherwise there's infinite answers. And on the AP test, everything's going to be radians. So we'll do degrees and radians just for the practice of it. But here is a trig inequality. So we want everything on one side to 0. We want to then factor it. GCF, try it. And then using 0 product property, this would equal 0. Or this would equal 0, which I'm going to just cut to the chase and subtract 1 and divide by 2. Now cosine equals 0 at 90 degrees plus 180k, or pi over 2 plus pi k. And here, alpha, ignore the negative, just think first quadrant. When does cosine equal positive 1/2? So it's 1 root 3 over 2, root 2 over 2, 1/2, 0. So it's that one, 1/2. So it's 0, 30, 45, 60 degrees, or pi over 0, pi over 6, pi over 4, pi over 3. What quadrants? We're in quadrants 2 and 3 if it's negative, right? So we ignore the negative first to figure out the reference angle. Then we figure out that the quadrants from the negative are positive. So x equals 60 degrees plus oh wait, not 60. 180 minus 60 would be 120. That's quadrant 2 plus 360k. And x equals quadrant 3 would be 180 plus alpha, 240 plus 360k. Now in radians, that would be x equals pi minus pi over 3, 2 pi over 3 plus 2 pi k. And x equals pi plus pi over 3, so it'd be 4 pi over 3 plus 2 pi k. So we want the answers from 0 to 2 pi. So that's going to be pi over 2, 3 pi over 2, 2 pi over 3, 4 pi over 3 in radians. So I'm just going to go ahead. I think I'm going to go ahead and emphasize that we do radians. But you could do degrees also. You could do both. So line check. What I do is I like to put the domain of the problem on here with these brackets. These will all be solid dots. Pi over 2. 2 pi over 3 should be next. It's not quite pi. And then 4 pi over 3 and 3 pi over 2. Test the value. Now on trig, I like to test 0 as much as possible as long as there's not a dot there. Because cosine 0 is 1, and it's false, true, false, true, false. So your answer is pi over 2, 2 pi over 3, bracket, union, bracket, 4 pi over 3, 3 pi over 2. Or in degrees, that would have been 90 degrees was pi over 2. Right? 90 degrees plus 180 is 270 degrees. And then 2 pi over 3, that was 120 and 240. So that would be 90 to 120 and 240 to 270. Okay, now I don't know if you remember what causes bounce on trig. It's not repeated even multiple roots. It's when sine or cosine equals plus or minus 1, which wasn't the case here. All right, here's another one. Cosine x plus 1. Okay, so cosine x equals 0. This equals 0, which gives you cosine x equals -1. That's a bounce. Because what happens is if you shift your graph up 1 exactly, then the bottoms just bounce off the x-axis. If you shift it down -1, which gives you +1 here, it means you shift it down to 1 unit, which is the amplitude, and you get the tops just bounce off the graph. So okay, cosine equals -1, right in the middle at pi, 180 degrees plus 360k. Or pi plus 2 pi k. So we have 90 degrees, 270 degrees. These guys are going to be these stars. So 180. Okay, or in radians, it'd be pi over 2, 3 pi over 2, pi. Okay, so line check. 0, 2 pi. These are solid dots, pi over 2, 90 degrees, pi, and 80 degrees, 3 pi over 2, 270 degrees. Okay, test point, I'm going to test 0. It's easy. Cosine 0 is 1, that's positive, which is false. False. True, true, false. So your answer is pi over 2 to 3 pi over 2. Don't break it up. Don't need to unless there's an open dot. Or 90 degrees to 270 degrees. So, little trig reminder. Give you one more example. So I'll give you a little tougher rational inequality. So I don't know if you think you do it, just try it. Pause it, give yourself a shot trying it. Otherwise, you need to move everything to one side. All right, first step. Combine these into a single fraction, so you need least common denominator. So that's going to be x squared minus x minus 3 over x minus 1. Leave the denominator factored, because that's all ready to go. The top, we got to blow everything up, multiply it all out, combine like terms. Try and factor it. Find the roots. Find the vertical asymptotes. Put them on a line check. Order left to right. So the ones on the bottom are going to be open dot. So open dot at -3. Solid dot -1. Open dot at +1. Solid dot at 3. Test the value. I like far right. 4. Positive, positive, positive. True, false, true, false, true. So there's your answer. And negative infinity, -3. Union, bracket, -1 to 1. Parenthesis, union, bracket, 3. Parenthesis, positive infinity. Parenthesis. Okay. So just move to one side. Combine into single fraction. Give least common denominators. Anyways, for today's assignments worksheet, I'm going to show you real quick how to do one of the problems in the front. It's just kind of weird, little fun little problem. It's called color mapping. So this is what this looks like. So the idea here, devise a scheme to color these maps in 4 or less colors. So you use a colored pencil or a crayon, or I'm going to just use some numbers right now. But this was devised that any map, and you think of all the different states and stuff, if you wanted to make the states and countries different colors, but you never wanted the same colors right next to each other so that you could kind of be able to tell where the different countries or different states are, you really should be able to do it anytime with 4 colors or less total. So this was one of the first major proofs ever done on a computer. So for instance, this one, I would like just, if you could use colors, but I'm going to go 1, and then this one can't be 1. It's got to be a new number. This one can't be 1 or 2 because it's touching, so it has to be a 3. This one right here can't be a 1 or 3, so it can be a 2. This one right here can't be a 2 or a 3, so I'm going to make it a 1. This one can't be a 1 or a 3 or a 2, so here's your fourth color. But I did it in 4, right? So next one, 1, 2. This can't be a 1, 2, so this is 3. This can't be a 1, 2, or 3, so this is a 4. This can't be a 1, 4, or 3, so this would have to be a 2. This can't be a 3 or 2, so this could be a 1 or a 4. But you can do it. So you could try that on these, and then your assignment is the problems in the back. Good review. There you go. Try it out. Check your answers.